Don't you worry.
Okay, here's number 9 on the homework. So
Don't worry.
first I'm just going to point out that we have 3 figures stuck together. We have this cone, this cylinder, and half of the sphere. So when we look at surface area and we go to calculate it, we're going to want to calculate surface area of the cone plus surface area of the cylinder plus surface area of the sphere. The cone formula generally has 2 parts for surface area. It has pi r squared plus pi r L for the slant height. And the pi r squared, if you remember, is the formula for area of a circle. So when we look at our cone, we actually don't want to include this circle because it's not actually on the surface of this figure. So we want to exclude from the formula the circle that we normally count as the base of the cone. So we're going to go ahead and we're going to eliminate that part of the surface area calculation and not include it. For the cylinder, so that was for the cone. For the cylinder, the formula is normally 2 pi r squared plus 2 pi r h. So that's surface area of an entire cylinder. However, again, we don't want to count this top circle or this bottom circle of the cylinder because they're not actually on the surface here. They're covered by a different type of object. And if area of a circle is pi r squared, we want to exclude 2 pi r squareds because we want to exclude 2 circles. So I'm going to go ahead and exclude this part of the cylinder formula. For the sphere, it's normally 4 pi r squared. But we don't want an entire sphere. The picture that we have here only covers half of the exterior of the ball or the sphere. So the adjustment that we need to make to that formula is that we want to divide it by 2 or multiply it by 1/2. So now if I go ahead and plug into these, for my cone, I want pi times r times L. The radius of the cone is going to match this radius of the cylinder right here, which is 3.5, which is also the radius of the sphere. So I'm going to leave a spot for the L, the slant height, and I'm going to come back to it in a minute because these other measurements seem a little easier to see. The height of the cylinder is 10. And again, the radius of the sphere matches with those other objects. It's being divided by 2. And so the thing we're missing here is this slant height. In order to get the slant height, which is this part of the cone right here, I'm going to have to do a little bit of work. So notice that that slant height connects here to the actual height of the cone and to the radius. If we separate out that triangle that we just built in the cone, and the slant height is what we're looking for here, which is the hypotenuse of that right triangle, we know that the actual height of the cone is 6 and the radius is 3.5. So we would do 6 squared plus 3.5 squared equals c squared. So on my calculator, if I calculate 36, which is 6 squared, plus 3.5 squared, let's see, I get 48.25. And then I'm going to go ahead and take the square root of that, which gives me 6.9. So 6.9 is going to be my slant height value that I'm going to use in here. And so then if we finish this calculation, which I'm going to let you guys do because you have the answer, you should get the surface area. You can leave pi in your answer or multiply it out in centimeters squared. Okay. When we're looking at the volume of the figure, it's still complicated because you have these combined figures. However, you don't have to exclude places because volume is more like filling up the object, And with or without the base of the cone, you would fill it up with the same amount of water. So volume doesn't really change here. We want the cone and the cylinder and the sphere that we see. So volume of a cone is 1/3 pi r squared h. Volume of a cylinder is pi r squared h. And volume of a sphere is normally 4/3 pi r cubed. And again, we want the entire cone and the entire cylinder. So the only adjustment that needs to be made here is that the sphere is still half of a sphere. So we want to divide this by 2 or multiply it by a half. And then we would just go through and plug in the radius and the height. So for the cone, the radius is 3.5 and the height is 6. For the cylinder, the radius is 3.5 and the height is 10. And then for the sphere, the radius is 3.5. And then I just have to make sure I include that half because I'm cutting it in half. And then that should allow you to calculate the volume, and that measurement will be in centimeters cubed.